Yeah. So that we can take that NM numerical methods. So here that all are problematics. There is no theorems here. So what is the numerical methods? Yeah. So what is the numerical methods and what are the topics will be there here? Okay. Uh, so numerical methods. So it is a one of the methods to solve the differential equations and solve that the function some given conditions. Okay. So first here the topic name is the finite differentiations. So the first topic is that finite difference. So the finite differences. That is finite differences. Okay. So what is the finite differentiation means? So first we are using the forward difference operators. So this is called delta. So this is forward difference table. Okay. So how we can draw the forward difference table means? So this is the x values and this is the y values, the corresponding. So this is x naught and this is a y naught. So y naught is the corresponding value of x naught and x1 and this is the y1. Next x2 and y2. Okay. Next x3 and y3 and x4 and y4. Okay. So first difference that we are taking that delta y. So delta y means the difference between these two. So that is become that we call the delta y naught. So delta y naught equal to y1 minus y naught. Okay. And next, now this is different between these two. Delta y1 that equal to y2 minus y1. And next this two that is delta y2 that we can write y3 minus y2 and this two delta y3 that is y4 minus y3. Okay. So this is the first difference. Next, let's go to the second differentiations. So before that, I will share it that I will share that PDF ma, then it's going very easy. Just I will share it, ma. Please be online. So this is the finite differences. So this is the finite differences, and this is the forward difference operator, lambda. Uh, that is called, see here. So just now we discuss about, no. See the difference between these two and the difference between delta y1 and this difference between delta y2 and this difference between delta y2. So now in the same way, the difference between these two, that is called the delta square y naught. Okay. And next, the difference between these two, that is delta square y1 and delta y2 minus delta y1. And this is the difference between these two, that is called delta y3 minus delta y2. So again, the difference between these two, that is delta q y naught, and this is. So this is called the forward difference table. Okay. So this is the forward difference table. So we can find that So forward difference table that just now we discussed. No, they are giving the x values and y values. The difference between the two values, that is the forward difference. Remember one thing, no? Delta y naught is become, listen, the delta y naught is become y1 minus y naught, and delta y1 is become that is y2 minus y1. Okay, so in the same way, delta yn minus 1. So delta yn, let's see what will happen. See that delta yn. So that is yn plus 1 minus yn. Okay, so this is delta y naught is y1 minus y naught, and delta y1 is y2 minus y1, and delta yn is yn plus 1 minus yn. So this is a formula. And one more thing, this is delta y naught, no? And let's go to delta square y naught. So delta square y naught is become delta y1 minus delta y naught. So delta y1, so from here we can write that is y2 minus y1 minus delta y1. So this is a y1, no? So this is y1 plus y naught. So that equal to y2 minus 2y1 plus y naught. So this is delta square y naught. So delta square y naught, we can write what is that? Y2 minus 2y1 plus y naught. Okay. See, I will share the PDF. Yeah. So let's see one problem. So form the difference table for the data 0, 0, and 1, comma 1, 2, comma 8, 3, comma 27, 4, comma 64. And they're asking to identify the delta square y naught and delta square y1 and delta y2. Okay. So x and y, this is x and y. So this is the x values 0, 1, 2, 3, 4. Okay, na? So y values 0, 1, 8, 27, 64. So 0, 1, 8, 27, 64. So first delta y. So this different 1 minus 0. So that equal to 1. Okay. Next to 8 minus 1, that is 7. Next to 27 minus 8, 19. And 64 minus 27, that is 37. Okay. Next, 7, 8 different is 6. And 7, 19 minus 7 different is 12. And 37 minus 19 different is 18. So then last thing, 12 minus 6 is 6. 18 minus 12 is 6. And 6 minus 6, that we are getting 0. Now he is asking to find out what is the delta square y naught. So this is the delta square, no? So this is the delta square y naught is become 6. Yeah. So this is delta square y naught equal to 6. And next, next what is asking delta square y1. So this is delta square y naught and this is delta square y1, that is equal to 12. Okay, and delta y2. So this is the delta y2. So that is 9. Okay. So this is the third degree polynomial. And the third order difference table is going to the 6 and the fourth order is going to 0. So the fourth order is going to 0, no? So this we can say that this data is for third order. Yes, how we can find that? See, f of x equal to x cube. F of x equal to x cube. Now come to backward difference operator. Okay. Now just we are change the symbol. Okay. So this symbol is called the nabla. So the symbol is called, what is that? Nabla. See, what is the nabla means? This is two difference. That is y1 minus y0. And similarly, the y2 minus y1. And similarly, y3 minus y2. So del nabla y1 equal to y1 minus y0. Nabla y2 equal to y2 minus y1. And nabla y3 equal to y3 minus y2. Okay. Next, nabla square y2. So nabla y2 minus nabla y1. And nabla square y3. So these two difference. Nabla y3 minus nabla y2. And what about the nabla cube by 3 means the difference between these two? What is that? Nabla square by 3 minus nabla by 1. See, one thing I will explain to there. This is delta y naught will become. So that we are writing what is that? Y1 minus y naught. So same thing here, the nabla y1. That's we can write y1 minus y naught. This is delta y naught and this is a nabla y1. So that is the little difference between there. Okay. So there will go one problem with nabla y1. So before that, see, just now we discussed no delta y naught equal to nabla y1 and nabla square y2 equal to delta square y. Okay. C1. The shift operator E. So the shift operator E is defined as delta I naught equal to yi equal to yi plus 1 or E dash yi equal to yi plus r. So that is the operator will shift to yi to the next values of yi plus 1. Okay, so this is the shift operator. So that means we can write y naught. So y naught we can write what is that? Y1. So similarly, EY1. So EY1 we can write what is that? Y2. Okay, so this is the top. So that is the shift operator. Okay, and next the averaging operators. So what is the averaging operators means? That we can write the mu. So just now we discussed about the shift operator, no? So averaging operators that mu equal to 1 by 2 e power of 1 by 2 plus e power of minus 1 by 2. That is u y naught equal to 1 by 2 e power of 1 by 2. Just now we discussed that. So y 1 by 2 plus y minus 1 by 2. Next is central difference operators. So this is the central difference operators. Seema here that in the short answers we can expected the questions here. Show that delta equal to e minus 1. So delta equal to that we can write the difference operators e power of 1 by 2 minus e power of minus 1 by 2. Or if we are taking that 1 by 2 is both side is common, that is we are getting e minus 1. Okay, and this is here the relation between the various difference operators. So what is the relation between that nabla and delta? Okay, so it can be that linear operator nabla and delta. So we know that we know that what is that delta f of x equal to f of x plus h minus f of x. So f of x plus h that we can write e into f of x minus f of x. That we can write e minus 1 into f of x. Now both side we cancel that f of x and we are getting that delta equal to e minus 1. So this is a very important for the short answers. No? So this is in the examination they are asking to prove that equal to e minus 1. So this is the procedure. Okay. And next, nabla. Then before that is delta. No? Now we are going to see the nabla. So where it is happened. Mm. Now we can see the nabla. So this is nabla f of x. So that equal to f of x minus f of x minus h. Just now we discussed about now f of x minus h equal to what is that? E power of minus 1 into f of x. Okay. So f of x minus e power of minus 1 into f of x. Let's take that f of x is common. That's become 1 minus e power of minus 1. So 1 minus e power of minus 1, that we can take 1 by e. 1 by e. Okay. So that e minus 1 by e into f of x. So otherwise, this we can write nabla equal to, so nabla equal to 1 minus e power of minus 1. Otherwise, we can say that nabla equal to delta by e. Yes, okay. That is no need. And one more that important formula, uh, that mu square from that. This is that mu square equal to 1 by 4 into e plus e power of minus 1 plus 2. That is 1 by 4 e power of 1 by 2 minus e power of minus 1 by 2 whole square plus 4. So here what is that? We are adding plus 2, no? So plus 2 we can write, plus 4 minus 2 we can write, no? Okay. So this we can write e power of 1 by 2 whole square plus e power of minus 1 by 2 whole square. Okay. Minus 2 into e power of 1 by 2 and 1 by 2. So that's we can write e power of 1 by 2 minus e power of minus 1 by 2 whole square. So this completely we can write what is that? Delta square. So when you are multiply with 1 by 4 inside, that is become 1 plus delta square by 4. And it is also important, the theorem, they are asking to prove that mu square equal to 1 plus delta square by 4. Okay, next. Mu into lambda. So that mu into lambda is 1 by 2 into e power of 1 by 2 plus e power of minus 1 by 2 and into e power of 1 by 2 minus e power of minus 1 by 2. This we know that is e, and this is we know that e power of minus 1. And just now we proved no that e equal to 1 plus lambda and e power of minus 1 equal to 1 by 1 plus lambda. And if we are taking to the LCM, so 2 plus lambda by 1 plus lambda, and that is lambda by 2 and 1 by 1 plus lambda plus 1. So 1 by 2 lambda into e power of minus 1 plus lambda. So that's we can get mu into lambda equal to lambda into e power of minus 1 by 2 plus lambda by 2. Okay, so this is the one. Hmm. So they are giving the y0, y1, y2, y3, y4, and they're asking to find that y power of 5. So using the difference table, so how we can getting that y power of 5? That is the important thing. See here. So this is y0, y1, y2, y3, y4, and is asking to find that y5. So x, y, delta square y, and delta cube y. So we write the values of 0, 1, 2, 3, 4, 5. Okay. And corresponding values are -5, -10, -9, 4, 35, 4, and 35. Now see the difference 90. The 5 is that 90. So let's take the difference here. -10, minus of -5, that is become -5, 1, 13, 31, 55, 24, 18, 12, 6, 6, 6, 6, and the remaining that will be going to that 0. Okay, let's see the next step. So this is delta y square, no? Delta square y to 6. That is equal to what is the delta square y3 minus delta square y2. So from there we can write delta square y3 equal to delta square y2 plus 6. So that is 18 plus 6, 24. So similarly, delta cube plus 24 equal to delta 4, 55. Next, additional we have to add. But in that examination, so how we can find this one means, so this is, let's take x, okay? So when you take it is x, then this is become x minus 35. Yes, na? X minus 35. So x minus 35, and this is become x minus 35 minus 31. Okay. So this value is become what is it? X minus 35 minus 31. And similarly, again, this is become that 18. The next differentiation is become that 18. So that answer is become 66 and the 88, 96. So x minus 90, 94, sorry, x minus 94. So again, this is here 6 is there, no? So 80, that is become, sorry, 80, 84, that is become, again side that is become 90. So x equal to 90.